Hello everyone, I hope you are all as excited as I am for this video, because in this video, all this hard work we've been doing, we're finally going to get to our goal of calculating TF-IDF. So, if we look at this Wikipedia document again, in the last video we just finished calculating the number of documents where the term T appears, and we know that the N, which is just the total number of documents, is easy to get. We're just going to call the length function on the documents list, which in our case will be 3, and then we'll just take the log of that. Once we have that, which is the IDF, we'll multiply it by the term frequency we calculated in earlier videos and get what we're looking for, the TF-IDF. So let's get to it. So first, I'm just going to write a little comment here. It's going to say calculate, and we're going to calculate the IDF. And then let's start by making a new dictionary of IDF, and there's not going to be any duplicates, so we'll call it IDF no duplicates. And the reason I'm saying no duplicates, if you haven't seen the other videos, is just because there are some words that are coming up over and over again in a sentence, and we don't need that duplication of words. So that's why I'm calling it that. And then what I'll do, and if you're kind of curious what I've done so far, just look back at the previous videos and you'll see sort of how we ended up like this. All right, so then what we're going to do is we're going to loop through for I in range 0 to, oops, that's not a 0, that's an O, 0 to the length of the normalized term frequency that we calculated earlier. So we're going to loop through for the length of that, and then we're going to make a new list for the calculation of IDF. So list of, I'm going to say IDF calcs is going to be equal to a new list, which is great. And then we're going to do a nested for loop. So now we're going to go for the word inside of the normalized term frequency list. Now, you might be wondering, well, what is the normalized term frequency list? Let's just take a look at that. If I just comment, whoa, I did not want to do that. I just want to comment this out for a moment. Gosh, why am I having so much trouble with this? There we go. So let's just print this out quickly. So we're going to print out the normalized term frequency list. And let me just comment out this, and let's run this program. And here it is. So this is the normalized term frequency dictionary. I think I was saying list. I'm sorry. It's a dictionary. And what we have is each of the sentences with the normalized term frequency in it. So that's what we're going to be looping through. Let me just backspace this out of the way now. Comment this code back in. And we're going to get the word. Now by word, I mean this, right? This tuple. So this tuple we'll call the word. So that's what we're getting for this loop. And we are going to then do another loop inside of this loop. There's a lot of loops in here. So we're going to go for the range in 0 to the length of this dictionary we made up here with the counts of how many times the term T appears, oh man, I keep saying this wrong, but this basically, the number of documents where the term T appears. That's what is contained within this dictionary. So we're going to go looping through this so that we can get that number out to ultimately do the division, which is what we want to do. So let's do it. For X in range, so what we need to do first is check, okay, is this word, so if the word, but we can't just do word because it's a tuple. So we want to get access to the first part of this tuple, which is if word 0. So index 0 of the tuple is the word. Index 1 of the tuple is the normalized term frequency. So we want to just see, okay, so is the word inside of this dictionary of number of documents with the term inside it. So then what we're going to do basically is I'm just going to copy and paste this into here. And then we're going to access that key to the dictionary, which is the range, right? So in this case, X in range from here, this is going to be 0. And then since it's a dictionary, we want to grab the first element out of it. And not an I, but the 0. Because again, it is a dictionary of tuples. So just to make this clear, if I comment this out again, and I comment this in, because this is the dictionary, this dictionary is the same as this dictionary, so let's just take a look at this. So see, again, it's the same setup as the normalized term frequency. It's a dictionary, and each key of the dictionary is a list of tuples. So when we grab this first, we access the first index of the dictionary, which is 0. We're going to then grab the first index of the tuple at that point, which in this case is going to be 0. So if the dictionary, so just to make this clear maybe, if we then put 0 here, for example, what we're going to see is just this sentence, right? This first sentence, rather than, or sorry, this first word, I should say. So if I run this again, we'll only see the. So if I run this again, and you see we only see the. And then if I access this 0 again, we will see just the, because 0 is the 0 index of this tuple. And then you see we see the. Now once we change this, let's say to key 1, we will see the next word, which is universe. So if I go back to just printing up the whole dictionary, you'll see that it was the and then universe. So that's sort of what we're going to do. That's what we're doing. And I know it's a little bit confusing, so that's why I'm sort of printing it out as we're doing it. So it's a little more clear what is happening. Because even I get lost. I get lost going through, right now, what are we in here? Like the third layer of this loop? It's easy to get lost. So it's helpful for me too. So now that we're there, now that we've accessed this portion, which is the lower part here, the denominator part of this calculation, and we know we had the length of the documents, now we can start doing the calculation for each term. So now that we're in this loop, what we can do is, if it's that word, we're going to append to this list up here that we just made. So I'm just going to copy this, put that there, dot append, and here is where we're going to do the math. But we want to know which word we're dealing with. So again, I'm going to make another tuple. So we're going to take word 0, and that's going to be the indication of which term it is, comma, right, to indicate that this is a tuple with the parentheses around it. And then let's do the math. So we know that we have to do some division here. So we're going to take the length of documents, and then we're going to divide that by the dictionary of words, which is up here, right? The dictionary here. And then we want to access whichever index that we're at, which is X, just as we did before. But instead of accessing the word, right? Instead of accessing this portion, the word, we want to access the count. So that's why instead of putting 0 there, we're going to put 1. All right. But if we take a little bit of a closer look at this calculation, it's not just this division. We also need to take the log of it. All right. And then if we look a little bit closer, we can see it's common to adjust the denominator to 1 plus. Now that's because if the term, it just says it right here, if the term is not in the corpus, this will lead to division by 0. Now in our case, we made the list of terms, this list of vocabulary from the corpus. So therefore, all of those words will be there. So I'm not going to do the 1 plus here. Maybe I should. And if that's the case, please let me know. But I'm going to leave that out for this specific example because we got the terms of the corpus, directly from the corpus, right? Directly from this list of words. So therefore, there can't ever be a situation where one of these words doesn't exist anywhere. At least I think so. So hopefully that's right. Now, before we got all into that mess, I had said that we needed to take the log. So we want to do that. And to do this, we have to import something that comes in with Python. We need to import math. So way up at the top here, let's do our one import that we need to do. And we're going to import math. And then what we can do with this is go math.log. So this is the great part about this. It's going to be super easy. We just go math, then we go dot to access this method log. And we're going to take the log of this division, right? So we're going to get the total number of documents, which is the length of documents, and divide that by the number of documents with the term inside it. All right, so now that we've done this, we want to capture this data, and we need to get out of this for loop and out of this other for loop, and this is where we want to add this dictionary to this dictionary here. So we're going to put that there, and as you can see, it jumped back, so we'll make sure we're not in the wrong for loop. And then what we're going to do is grab I, because that's the index of this dictionary we want to add to, and we're going to add this list of no duplicates. List of IDF calcs is what I want to add. List of IDF calcs. There it is. Okay. So I think we did it. I think we've done the IDF calculation. So let's confirm this. Let's see if this is actually right. So let's print this out. Dictionary of IDF. Whew, I hope this works. Let's see. Let's see if this is going to work. Let's run this program. Okay, so we got an error here. So if word 0 equals dictionary number, blah, 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 type error, integer object is not subscriptable. Okay, so where are we looking here? Here. Okay, so after a little bit of looking into this, I realized I made a little bit of a typo in the code here. So basically, this is right here is the problem. So this is the dictionary, but we need to access the sentence of the key of this dictionary. So I just needed to add I right there. So then now if I rerun this program here, there we go. We can see that we have the dictionary with the IDF calculations. Now, so if we were to, let's say, try to validate this calculation with, let's say, the calculator here. So if I go to the calculator here and I say, well, we know that, you know, there's 3 documents and the word the appears 3 times. Okay, that's great. So we take 3 divided by 3, and that's good, that's 1, okay, and then we take the log of that and we get 0. Okay, great. So that looks like it's right. But then let's do the same check on the universe one. So in this case, right, so let me just show you what I'm doing here. So we got 3 sentences, that means the total number of documents is 3, and only 1 document contains the word universe, just 1. So with the TF-IDF calculation, what this means we should do is take 3, the number of documents, and divide that by 1. Okay, great. And then we take the log of this, and then we see that it's 0.477. And then we look here and we go, that doesn't match. That doesn't match at all. So let's now to try to sort of explain what's happening here, let's just print math.log of 3 divided by 1, right? That's what we were doing. So if we print this, run this program here, we can see, that's strange. It doesn't match. Why is that? Well, if we go quickly look at the documentation for Python, so this is 3.7.2, but actually my version is 3.6. So then if we control find for log and we just kind of look, okay, here we go. So we can see with 1 argument to log, it uses the natural logarithm, which is to base e. I assume this is not using to base e. So what we need to do is look at here, and we had to see, okay, so log, it doesn't say what base I'm supposed to go to. So this is kind of a confusing part for me, and sort of a limitation of my understanding of sort of the mathematics and, you know, computer science or mathematics. What is the standard? Is this the log base 10? Is this a log base E? Is this log base 2? I'm actually not sure. So I'm not sure what the right log to use is here, but I'm going to go with just the math.log, which I guess is the log base E. And we're just going to go with that, and hopefully that's right. Now, if this is wrong, though, please let me know, because I'm not completely sure which base to use for this specific situation. But assuming that it's log base E, it looks like this has worked properly, because if we do the math calculation by 3 divided by 1 and take the log of it, excellent, we're getting the right number. What that means is we have probably done this loop correctly. Let's validate one more thing. So we know that has comes up only once, so that, of course that's going to be the same. What about vary? if we look at the sentences up here, we see that vary comes up once in one document and then once again in this document. So that's 2. So if we take 3 divided by 2, we should see here that it's 0.405. So we run this program. Great, 0.405465, 0.405465. So at least we know that this loop is working properly. Again, please let me know if anybody knows what exactly, how to use this log, log base E, what is that? But assuming that we're using the right log, let's continue on. Let's now calculate TF-IDF since we have now successfully calculated the IDF. So we're going to do another loop. And let me just make a little note here. Let's say multiply TF by IDF for TF-IDF. Oops, IDF. So let's do the full calculation now. So if we make a new dictionary of, and we'll call it TF_IDF, and we'll set that to a empty dictionary. And then what we'll do is we'll loop through again. So for I in range, and we'll go from 0 to length of the normalized term frequency. And what we're going to do is we're going to make a new list of, and we'll call it TF-IDF, and we'll set that to an empty list, which we will then later add to this new dictionary. Let's take the TF, the term frequency sentence, and set that equal to what we've already calculated before. So we know the normalized term frequency, and let's make sure to actually access that sentence. And now let's take the IDF sentence, which we've also calculated, and set that equal to the dictionary of, let's see here, IDF no duplicates. And let's grab that. Okay, great. So now we've got the TF and the IDF portions. And then now let's loop through this. So for X in range 0 to the length of the TF sentence. And then what we're going to do here is we're going to take that list of TF-IDF and append to it so here we go. So now what we're going to do is we're going to make another tuple again. So let's grab the word, right? So the first one is going to be the word like we've usually got it set up. So X, we're going to access that, and then 0, right, is the 0 part of the tuple, which is the word. If we look down here again, so 0 and 1, so we want the 0 portion. Of course, it's not this dictionary, but it's set up in the same structure. So that would be the first part of the tuple. Oops. And then the second part of the tuple will be the multiplication, the product. So we'll take the TF sentence, and this time, again, we're going to go with X. Instead of the word, we want the value, which is 1. Multiply that with the star by the IDF sentence. And again, we don't want the word this time. We want the value, which again will be 1. So that's great. Then what we're going to do is take that list and append it to this dictionary, or add it to this dictionary. So we're going to say dictionary of TF_IDF at the I position of this dictionary, and we're going to set it to the list of TF-IDF. Excellent. So now what we need to do is see if that's right. So let's print dictionary of TF-IDF. All right, this is definitely a big moment of truth. Let's comment this out, run this program, and see what we get. Okay, here we go. So now we've got this number and this number and this number, and hopefully this is the term frequency inverse document frequency. So what we can do is let's do some math. So we know for anything multiplied by 0 is 0. So that at least that's good. At least we know that's right. But let's try to do the math on, let's say, this universe, the universe word. So we know, let me do this underneath here. So if we print math.log and we take the log, and we know it was 3 divided by 1 in that case, that would be the IDF. And if we print the normalized term frequency, we'll be able to get that number. So let's get those numbers. So the normalized term frequency is 0.15, and then the math, let me we're getting confused. I'm getting confused. There we go. That's better. So the normalized term frequency for universe is 0.1428, and then the IDF for universe, which was 3 divided by 1, is 1.098. So if we get the calculator here, we just do a little bit of math. We just do some multiplication. Let's take 0.142857, which is the normalized term frequency, which we are accessing here. As you can see, normalized term frequency. And let's multiply that by the IDF of 3 divided by 1, because we know that universe only comes up once. So let's multiply this by 1.0986. Okay, good. So we get 0.16 about. And of course, I've now, let's comment these out. Whoops, I don't want to delete them. Oh, just doing it again. There we go. And let's comment this back in. And let's run this, and let's look at universe. So we got 0.1569, and we're getting 0.1632. Now that is pretty close. That is pretty close. Let me see here. Maybe if I add in some more decimal places, we'll get a more accurate result, hopefully. So let's grab the universe, which, okay, so 0.1428571428. Okay, so that's up to here. And let's multiply that by 1.098612288. And that's it equals. There we go. So 0.15. So if we look here, 0.156944. So good. There we go. So it looks like we're doing the TF-IDF calculation at least as correct as we can for how we've set it up. In the next video, what I'm going to do is I'm going to look at NLTK and use the same 3 sentences and try to calculate TF-IDF with their classes in that module and see if we get the same result. And another interesting thing I found when I did that is I had to make a slight adjustment to the source code when I was doing it. So I'll go through that and show everyone that. I mean, of course, because I made that slight adjustment, that could mean, it's even more wrong. But we'll see how it is. So thanks so much for sticking with me all the way to the end of this video or this tutorial. And I hope this was helpful for everyone. Please let me know if I'm making mistakes along the way. I definitely have probably more questions after doing this, but I feel like I have a better understanding of it now at least. So please like and subscribe, and I'll see you in the next video.